In this video I'm going to be going through the process of designing and 3D printing these 3D ripple cube sculptures. So a 3D printer is effectively a computer controlled tool which takes a 3D model which is digital on the computer and converts it into a physical plastic object by a process called fused deposition modeling, which basically melts and extrudes plastic in the correct format that it forms a model. So obviously the first step in creating these ball cube models is creating a digital file, which is going to be a 3D model which is then going to be physically recreated by the printer. And this model I'm going to generate in a program called Blender, which is an animation and rendering program. Blender has a feature called dynamic paint, which allows you to make the canvas of the dynamic paint into whatever sort of material that you want. And if I select that material to act like a fluid, then waves will propagate and interact with each other just as waves would do on the surface of water, which is perfect for my project. I animated a ball so it would pass straight through the centre of the fluid cube, and that would create waves which would then propagate across the surfaces. There are a lot of different parameters that can be adjusted, such as the speed of the ball, the time in the simulation, and also the actual real life size of the waves that are being generated. And this all affects how the outcome of the waves look, and it just takes a lot of trial and error to get waves that look like real water waves and give the correct aesthetic that I'm looking for. Eventually, after quite a lot of trial and error, I managed to find the right parameters to create waves that looked as I wanted them, and then I could export the 3D models as STL files. So the next step is to take this 3D model and import it into a program called a slicer, and this is what's actually going to take the 3D model and slice it into layers and turn it into G-code, which you can send to the 3D printer, and the 3D printer is going to use that as a toolpath, which is basically just a string of coordinates which the hot end will follow and distribute plastic in the correct places to form the model. So I'm going to be using a program called Cura to generate the G-code for this model. The model can be imported, and then again there's loads of different parameters that you can adjust, and these affect a lot of different things, including the print quality, the strength of the final model, the weight of the final model, the time that it takes for the print to actually be completed, and also like how large the print is and how thick the layers are. All of these different parameters affect how well the print comes out, and they all have to be adjusted to the correct settings to make sure that you get good results. Once the G-code has been generated in Cura, I can then export that onto a memory stick, plug the memory stick into my 3D printer, heat up the 3D printer to the correct settings and load the right filament, and then the entire thing will print for me. And that's basically all of the work on my part done. The printers that I'm going to be using for this are my two homemade Prusa i3 3D printers, and I made both of these, so they're not as accurate as commercial 3D printers. However, with the right fine tuning you can still produce really high quality models. Finding the correct settings for a certain model and a certain filament type are always a bit of a gamble and a bit of trial and error, as it is with most of the things in 3D printing. And as you can see with these blue models, I didn't get the settings completely right because there was a bit of delamination between the layers, and also there was a little bit of sagging on the overhang because I didn't put this correct support material in, and that's meant these models haven't come out as accurately as they could have. I then reprinted the same models but a little bit larger on my other 3D printer, and on one of the models I actually managed to print it with one single layer going all the way out around the outside, so it was a hollow model and there was no infill on the inside of it, and that came out quite nicely and was surprisingly strong. And on this printer I used the correct settings this time, so the prints came out really high quality. So that is the process of how I make these 3D ripple cube sculptures and how I 3D print them, and I hope this helps you to understand how the 3D printing process works.